Mike, what are you excited about talking about today?
I'm really excited that the commercial crew program is one step closer to opening up spaceflight for the rest of us.
That's awesome. And Sarah?
I'm excited that we may have a new technique for discovering rogue planets. We don't have to rely on luck.
Yes, thankfully. And then on the observation deck, Jared, what have you got?
Well, I've got Peter Beck in person, in studio, the CEO of Rocket Lab, to talk about what they're doing in the future.
Awesome. All that and more on this episode of Tomorrow Orbit 11.30.
Good morning. How's everything up in the sky?
And welcome to Tomorrow, everybody, episode 11.30. And we are so excited to have Peter Beck here today, the CEO and founder of Rocket Lab. Peter, thank you so much for coming on the show today.
Oh, look, I'm a big fan. My absolute pleasure.
Yeah. So we're just going to go straight into it today because, I mean, we're just so excited to have you here that we put the interview first. So that's how it's going. So why don't you go ahead and just tell us a little bit about yourself? Because we all have that moment that sort of like sparks us getting into space. So what was that moment for you that sparked you getting into space?
Yeah, I mean, for me, it was from a really, really early age. So I think, my father tells a story. I was about 2 or 3 years old, and he had taken me outside and shown me, a re-entering spacecraft. And, it was shooting across the sky in the brilliance. And for me, it was like, goodness, what is that? And he explained to me that humans had made that thing in the sky. And I'm like, okay. So all these other dots and stars in the sky, were they made by humans too? And he's like, no. Those are suns, and they've got planets. And I'm like, okay, like our planet, yep. So are people on those planets? And he's like, well, the jury's out on that one. And at that point, for me, it was just all about space. It was like, this is the most incredible, captivating thing. It's just a mind-blowing experience. And ever since then, that's what it's all been about for me.
Yeah, and how did you kind of continue doing that? Because you kept your interest for quite a long time because you still have it. So how did you continue to pursue that? With that?
So for me, it's always been about the rocket. Everything else is there to support and grow the rocket. So, as I went through school, I built telescopes, and I've always been very, very practical and good with my hands. So, I started building rockets at school, and then when I moved into, gainful employment, I started off as an apprentice tool and die maker, and I would do the day shift at my job, and then the night shift would always be building rockets. So my whole life I've always sort of run 2 shifts. Now it's just 2 shifts of rocket instead of 1 shift of real work and 1 shift of rocket. But it's for as long as I can remember, it's always been about it.
So what was the first real project that you worked on by yourself that you built together straight from beginning to end, and you were just in awe of the fact that you were able to make that? What was that project for you?
Well, I mean, I've built a lot of stuff, hovercrafts and
hovercrafts.
Yeah. I mean, I just build stuff. That's what I do. So, but if we just limit it to rockets, the first serious rocket program was my hydrogen peroxide rocket program, and it would be fair to say that I lacked the kind of generally accepted common resources and PPE equipment when I first started with that. And getting hydrogen peroxide in New Zealand was really difficult, and I managed to source some. And I remember that it was very difficult to source the concentration that I needed, so I managed to source 50%. And it arrived on my doorstep, and the guy had left it in the sun, and it wasn't in an approved container. So this arrived on my doorstep, and the container was spherical because it was hot and outgassing. And that was the first thing. I was like, ooh, this is not so good.
Yeah.
And then I proceeded to build a garden shed and put inside all the distillation equipment that I needed to get it up to 92%, where it was useful as propulsion. And that was the first really deep program where I spent a lot of time researching and understanding. And although it kind of sounds dodgy, one of the things that I've always, it's been consistent right through throughout my life and career is really getting an understanding of the fundamentals before doing anything. So I knew what I was biting off. Like I knew that the spherical container sitting on my doorstep was not a good situation.
Yes.
So,
So having that good foundation is kind of what allows you to end up moving forward with those little projects that you had at that time.
yeah, exactly, and making sure you have that deep understanding that of the fundamental engineering, the fundamental chemistry, and the fundamental physics.
So eventually you reached a point where I guess what I would call a very well pursued hobby started to become something that you were thinking about maybe doing professionally. And what was that point like for you?
So I mean, the way if you look at my career, it was always about trying to get to this point, and further, of course. And my original plan was to do a trade because I needed to have great hand skills to be able to build the engines and the systems that I wanted to do. Then go to university and get the good theoretical grounding as well, and then go and work for NASA or one of the large defence primes as a young child wants to go and do. And that was the plan for quite some time, and I ended up at a New Zealand government laboratory doing advanced materials and structures, mainly in composites and superconductors, and went on a rocket pilgrimage trip to America. And really, the whole point of it, I spent a month over here. The whole point of it was, get a job at NASA or get a job at Lockheed or really,
aim for that big contractor.
Yeah, and as a guy sitting back in New Zealand, that's what you do, right? And I came over here and I learned two things. And I went and visited all the little shops in Mojave. I got escorted off the campus at Conga Park, Rocketdyne, and did the whole shebang. And the two really things that I learned. Firstly, what I was doing back in New Zealand was fundamentally no different than anybody else was doing in the Mojave Desert. Like, I'd always felt that what was happening there was just such a higher level to what I was doing. And I get there and it's like, well, their engines are the same, they're having the same problems I'm having, using the same instrumentation. Some of their injector designs actually really suck. So it was understanding that actually, the level I was operating at wasn't a million miles away from everybody else. And the other kind of thing that I realised is, for me, it's always small launch was always really, really obvious that's where it was going to go. I mean, if you think of a spacecraft, what is it? It's solar panels, it's batteries, it's electronics, and it's a sensor. And what's in a sensor? Well, it can either be some optics or generally there's more electronics. So it was really obvious to me that spacecraft were going to shrink, and if spacecraft are going to shrink, then you need a vehicle to service that. So, so right from day one, and when I was stomping around America here, and this was back in 2006, nobody was really focused on doing that. Like, you talk to the big primes and NASA, and it's like, yeah, no, that's not that's not where we see it going. So that was kind of the impetus of starting Rocket Lab. I flew home on a 12-hour flight back to New Zealand, and I spent the first half of the flight thinking, well, my dreams are crushed. This is not how it was supposed to be at all. And then the other half of the flight, doodling logos, just thinking, well, screw it, I'll do it myself.
So that was the motivator.
Yep.
And that's pretty potent, I would imagine.
Yeah.
So you get back to New Zealand, and what do you do at that point?
Well, you quit your job. That's the first thing that anyone does, right? That's
just throw that resignation letter in. Sorry, I'm out. So
it's like standard entrepreneur practice. So I quit my job and managed to raise a small amount of private equity. And I knew that I needed to build credibility and I needed to build capability. So I spent the next couple of years working away building our first sounding rocket, which was we called RTL1, and we launched that in 2009, and we became the first private company in the Southern Hemisphere to have ever touched space. And that kind of opened up new opportunities. We did a lot of work for DARPA and Lockheed, and we kind of bootstrapped for a number of years in a stage where it's really about building, like I say, credibility and capability.
And that credibility, was it sort of working with other companies? Was it hardware? Was it like a combination of things working together?
No, it's just doing stuff.
So actually getting out there and doing it.
Yeah. Look, I hate PowerPoints and PowerPoint companies. I'm a strong believer in if I'm going to show a PowerPoint, it's got real hardware in it, not animations and kind of dreams. So for me, it's all about real hardware and being real, and that was one of the reasons why we were so successful in raising capital in America. Is we didn't turn up to the VCs with PowerPoints and vaporware. I turned up to our first VC that we ultimately raised the first round on, Khosla Ventures. with a blueprint of the rocket, and it was like 20 meters long. It was like a 5-to-1. Nearly 2-to-1 kind of scale of blueprint, and rolled it out on the boardroom table and said, here it is, it's designed. And I had an electric turbo pump in my luggage, and I just picked up an electric turbo pump and said, here's the electric turbo pump, it works. And it's not I'm going to do this, I'm going to do that. It's like this is it.
So I've done parts of this,
Yep.
and it can go further than that. That's kind of how you did it in front of everybody.
Yeah,
So-
laid out a clear plan, because you have to understand, raising capital for this kind of venture, even especially back in 2013, you look what it looks like. Like, I'm a New Zealander from another country that has no space industry. I'm turning up with a rocket that the market is obvious but not super obvious for. And it's got a whole lot of new technology that's never been done before, like electric turbo pumps and carbon composite, and a whole lot of technology risk. And by the way, we're going to need a bilateral treaty and New Zealand government to create a whole lot of regulation so that we can launch out in New Zealand to get the launch rate. And if you write everything down on a piece of paper, it's a leap of faith.
Yeah, that's a really tall mountain to climb in order to get up there with it. But you guys went through it.
Yep.
And you made it happen.
Yep.
And what were some of the struggles that you guys had to contend with at that time?
Oh, you best not to look back on that stuff. It's just depressing. So I think look, if you want to build a rocket, that's one thing. If you want to build a launch site, that's a whole nother. If you want to do both and also build a large successful rocket company, talk about barriers to entry to the market. That's a tough game.
Yeah, I think a lot of people forget about the fact that if you are a company, you don't just have to worry about the rocket. You have to worry about the launch site. You have to worry about the ground support equipment and everything that goes with it, and making sure everybody around you is happy, both like governmentally and
community.
And making sure that that goes smoothly.
Like I say to everybody, Rocket Lab is a third the rocket, a third infrastructure, and a third regulatory. I mean, we had to build roads, blow fibres, upgrade internets to entire townships just to support the launch site. So it's huge.
So you guys ended up bringing in a lot more, it sounds like, than your typical sort of like startup aerospace company would, simply because of your location.
Yeah, absolutely. So when we say we're vertically integrated, I mean we own everything from the launch site through to the roads, through to the launch vehicle, all the downrange tracking assets. We own them all. So yeah, it's a very vertically integrated. But that's what you need to move the needle. Like, you can't move the needle if you just go out, do the same thing off the same launch range with the same amount of frequency. You don't move the needle.
Yeah, and even the tracking assets you said you guys own. So wow, that's a bit more than most companies here in the United States. Most of that's done by the Air Force or someone like that.
Exactly. Yeah. So we own all at the launch ranges. We've got a couple of 5-meter dishes. Then on a remote island 500 kilometres away from New Zealand, we own another 5-meter tracking dish. Then we've got some in Cork and Azores. We own a whole tracking network.
Wow. So you guys are starting to, so let's just go back to when you're kind of working on your first Electron, and you're trying to figure out the things that you're going with that. What's that period like? How's that going in generating that and getting that from that blueprint out to the launch complex itself?
Yeah, so when you're climbing a mountain and you're climbing up and you think, this is terrible, why on earth am I doing this?
Yes.
And then you get to the top and it's like, it's okay, but it's a bit windy. And then you get down to the bottom and then you're having a beer, and at the bottom it's like, that was awesome.
Yes.
It's kind of like that.
Nice.
So, during that time, it was just, it was a small team, and we were just doing incredible things. It was a really great time, and I think one of the special things about the company is that we've really tried and done well at maintaining that. Like, if you want to see what your potential is as a person, then come work for us. If you just want to cruise in there and do some stuff and cruise out, don't even bother. Like, if you want to actually see what you're capable of as a person, have huge responsibilities and huge projects, then you're the right person for us.
Yeah, really push that bleeding edge with it there.
Yeah.
So, and you guys have done that with things like composites.
Yeah.
So that's not something that typically has happened in rocketry. I mean, even just in aerospace in general. Most of the time it's like aluminum, lithium aluminum alloys and other things like that. So why composites? Why specifically that?
Yeah, so that's a great question, and I'll answer that in a number of ways. So, when we started the vehicle, there was 2 requirements that we wrote down on a piece of paper. Must be affordable, must launch every 24 hours. So every design decision and every kind of decision, not just design decision, but every decision within the company is based around those two requirements. So the composite tanks for us is, yeah, we can go with traditional aluminum tanks, which means we're going to be friction stir welding them, we're going to be passivvating them, and we're going to be painting them, and we're going to do all those kinds of things. Or if we did a composite tank, we can build this giant mega mandrel, as we call it, and we can just pop them off in one hit. And they're much more higher performance and much lower cost and much more mass manufacturable. So that requires you to undertake a big R&D program to get there, but the payoff is huge. It's the same with the electric turbo pump and same with the 3D printed engines. Huge R&D programs, but at the end of the day, that's where you need to be.
And we've got a really good question from Zwiebie that kind of goes into those sort of R&D programs and some of the interesting things that you guys have done, especially this one, because they're asking, what is the hardest part to get working in a turbo pump, and is an electric one a solution to get around the complications of a gas generator cycle, or is it just straight up better?
Yeah, it's a good question. I mean, so the gas generator cycle is, it's a great cycle, but it is a, thermodynamically complex cycle. The nice thing about electric turbo pumps is you remove all the thermodynamics out of it. So for us, if we want to do mixture control, propellant utilization, startups, shutdown transients, it's software. It's not actual, orificing pipes and all that kind of stuff. So for us, the electric turbo pump gave a lot more flexibility for the mission. On Ascent, we're continuously throttling the engines to maintain an optimum trajectory, and you can just do a whole lot of stuff.
So it's basically simplicity. With
it is, yeah,
in a sense.
It is, and for the scale of vehicle that we have, it makes a lot of sense. And if you look at what are the technologies that are really moving forward. Battery technology is moving forward at a great pace. And if you look at a gas generator cycle, it's 50% efficient. Now, an electric turbo pump cycle is 98% efficient, but you have the drag of having to carry batteries with you all the way, unless you're on our second stage where we actually eject the batteries, and then you end up at the same efficiency as a gas generator. But battery technology is getting better and better, so on our second stage, it won't be long before we're actually more efficient than a gas generator cycle.
So you plan to kind of upgrade as you go, as the technology gets better. So
bet on the technologies that are absolute sure to improve.
Yeah. So another question from our chat room from Melon Yusk is: are the tanks all composite?
Yeah, 100%.
100% composite.
Yeah,
so.
all composite.
And you guys on your rocket use RP1, rocket propellant 1, which is highly refined kerosene, and liquid oxygen.
Yep.
LOX. And usually composites don't do so good at cold temperatures.
In a highly oxidizing environment.
Yes, that as well. So
yeah.
they're typically not two things you want to combine together.
Yeah. So that was a huge research program. A lot of material science went into that to develop materials that were both resistant to microcracking, because that's one of the biggest issues with composite tanks, and also LOX compatible. So we ended up with a tank that is very similar LOX compatibility to aluminum, and of course no microcracking issues.
Yeah, and Samuel Price from YouTube actually has a really good comment that kind of talks a little bit about batteries. It says he's dying to find out how you feel about the coming advancements to battery tech and how that will affect the performance of your rockets.
Well, it's just all positive. Like, I mean, we started with when we started the battery program. I think I'm nervous to quote the numbers because they're probably wrong, but we're already between what we started with and what we can buy now. It's nearly a 2x. So it's a great on-ramp for increased capability.
Nice. And Billy M from YouTube also has a question that I kind of wanted to ask, or part of a question that I wanted to ask, which is: are there any plans to make bigger engines for other aerospace companies? And my general question, I guess, that I was going to ask with this is that
it's a bigger rocket question, right?
Are you guys going to
build a bigger rocket?
Well, I was actually going to be: are you guys going to build anything for anyone else, or is Rocket Lab just going to stay Rocket Lab as it is?
Yeah, no, Rocket Lab is staying Rocket Lab. We have a very defined mission. And if we can continue on this trajectory and continue to build and launch at a high rate, then we can actually have a significant impact to the world. Once you create space as a really frequently accessed domain, you can experiment in it, you can create things in it, and the thing that excites me most about the space industry right now is we're like the internet was when you sent the first email. That's like space. We've sent the first email.
Yeah.
If I went back to the time when you've just sent that first email and told you all the stuff that's going to happen, you'd just go, the guy's on drugs. But this is where we're at right now with the space industry, and it's just hugely exciting. So so look, I'm not building a bigger rocket. Have no intention of building a big rocket. I think where we're at right now, the key here is frequency, not mass. It's frequency. And we lift pretty much most stuff. Like very rarely does a customer say, "Well, my satellite's too big." And what we're seeing, in fact, is people are designing to Electron because we're trying to create this standardized vehicle and standardized frequency.
So with frequency, how important is frequency, and what kind of frequency are we talking about with Electron?
So frequency is everything. It's absolutely critical, from a guy who's launched one rocket this year.
Yes.
But it's absolutely critical. The whole program and all the factories we've built, it's all about making sure we can get frequency. Because once you have frequency, you have access to a domain. Think of America, where there was, what was it, like 18 times America went to orbit this year. So let's just take America and let's just say there's 18 freight trains that traverse the country, nothing else. And what would the economy in America look like if there was 18 freight trains that traversed the continent?
Not great.
Not great, no. So, you need your FedEx vans, you need that frequency to actually open the domain up for innovation and execution of new things to help us all down on Earth.
And to kind of talk a little bit about frequency, Tawicked in our chat room is asking, with your main goal being high launch rates on the cheap, do you have any plans to implement clean range policies on your present and future launch sites? And I guess I'll also throw in there that you guys chose New Zealand as your place to launch. Yep. Did the frequency of being able to launch from New Zealand kind of affect that as well?
Yeah. So addressing that first. So the first thing we did is remember the two requirements. Launch every 24 hours. Is we went to all the ranges in the US, in time they'll increase their launch frequency, but you have to remember that when Falcon Heavy launched, 562 airline flights were delayed. I'm talking. So you can imagine a guy turns up there saying, "I'm going to launch every 24 hours." It's like, that's tough. It's one of the things that doesn't scale well in America. Like disrupting air travel does not scale well in America. So we sort of took a step back and go, how are we going to solve this problem? And what you need for a launch site is azimuth. You need a wide range of launch inclinations and azimuths. So you need that. And you need the ability to launch really frequently. So you need to be in a spot where you can achieve these azimuths. But really, what makes an ideal launch site is a small island nation in the middle of nowhere. And that was New Zealand. And most people think that Rocket Lab is launched out of New Zealand because Pete's a Kiwi and he doesn't want to leave home. That's not true at all.
You're here in LA, so.
No, where the company's headquartered and we've got big factory now. I mean, we only launch out of New Zealand because that launch site is the only private orbital launch site in the world. We own it. It has the largest amount of launch inclination, so we can shoot sun synchronous right up to 37 degrees, and we're licensed to go right now every 72 hours. And there's just nothing there. Like, I've got nothing to hit until Chile. So there's just nothing there. It's
no boats.
Desolate. It's just desolate.
No planes.
No.
Not in that area.
There's one flight to Chile a week that I interrupt. That's it.
And you can kind of move it around that.
Totally.
So you've literally got nothing stopping you.
No.
If at least in terms of range and things like that.
Yeah. So the range piece is a huge piece, and you may have seen recently that we're looking to establish a US range as well for particular US customers. So the plan here is, the reason why it's called LC1 is not because it rolls off the tongue. There's LC2, LC3, LC4. Like, we'll be building launch pads in the next year or so, all around the show.
And a lot of people are asking about where are some of the places that you're planning to launch from, and especially in the chat room. There's of the questions I have, 6 or 7 of them in front of me right now are basically, are you coming to the U.S.? Where in the U.S? And other things like that. So.
Yep. So we're definitely coming to the U.S., establishing the launch site in the U.S. And we're running a competitive bid process right now. So within probably the next week, we'll make an announcement of which site we've selected to establish the US range from. We're having a little bit of a peek into the UK to see if we want a European-based launch site. And the other one we'll be looking for is equatorial, so we closest to 0 as possible.
And a really good question in our chat room from Astro YYZ is, has ITAR been a challenge, finding clients and staff for Rocket Lab?
Huge. I mean, ITAR is a massive piece of our business. We have engineers in New Zealand, we have engineers in America, and we work together very, very closely. But we've had an incredibly close relationship with the State Department since the inception of Rocket Lab, basically. And it's challenging, and sometimes it's frustrating, but it is part of your business, and you just have to work within the rules and regulations and make business decisions around that.
And also coming from our chat room, Citizen 71140 is asking, how is Rocket Lab dealing with issues of orbital debris and oversaturation? So,
I'm glad you asked me that question.
Yeah, I'm sure.
Excellent. Yeah, so you might be familiar with our kick stage. So that kick stage, we developed that for a number of reasons. But the way we intend, look, we're trying to be a super high frequency, perhaps the highest frequency launch ever. And with that comes responsibilities. You can't just be throwing stuff up there willy-nilly and just not worrying about all that kind of stuff. So we took a very forward-leaning approach right from the beginning and said, okay, we're going to do this sustainably and responsibly. So when we go to orbit, one of the reasons we have that kick stage, and it's got its own propulsion system, is firstly we go up into an elliptical transfer orbit with the second stage. So if we're going to a 500 kilometre circular orbit, we go to like a 180 by 500 elliptical orbit with the second stage, and then we separate off the kick stage. Now the advantage with that is because your perigee is down at 180 degrees, that second stage comes in way, way faster than it would any other way. And typically what most people do is they take their second stage and they do the second burn out of the transfer orbit and put their whole second stage in orbit. Now the trouble with that is a big lump of mass and it stays there for a long time. Most people don't realise that like 70% of the space junk up there is rockets. It's not spacecraft, it's rocket bits. So that's the first thing we do, is we put that second stage into that highly elliptical orbit, so it's dipping into the perigee and it's continually, getting brought down way, way fast.
Yeah, it's kind of touching up our atmosphere in that area.
Burn it up as quick as we can. So now we've got our kick stage, and it's got its own onboard propulsion system. So we do the kick and we circularize that orbit, deploy our spacecraft. Then the nice thing is we can flip that around and use all the propellant left and deorbit it or shorten the life way, way, way down. So at the end of it, we just leave the spacecraft in orbit.
Yeah, so you guys are doing good orbital stewardship.
And we consider ourselves leaders in this. We think it's very important.
Yeah, and kind of talking about that kick stage, Preston Croshaw from YouTube is kind of asking, can you give us any insight into the fuel that's used in the Curie engine on the kick stage? Haven't seen anything specific, just that it is green. I think it's a monopropellant as well. Anything you could tell us about it, or is that kind of super secret? So.
Nope.
So yeah, there's the can't talk about it for that there with it. Good question here from Miko1, which is actually kind of talking about something that you had on your second launch earlier this year, which was the Humanity Star, which I thought was a very cool idea with that there. And just why don't you just tell us a little bit about the Humanity Star?
So, as I explained at the beginning of the interview, the reason I got into space was my father took me out and showed me a shooting star. And that was my overview effect, right? That was when I was like, whoa, there's way more in this planet and way more in this universe than just me sitting on the ground. And the whole overview effect is incredibly powerful when people go into orbit. And I was trying to create an overview effect, the same overview effect that I had, down on Earth. And the message was always, take your child out, go out yourself, look up at the Humanity Star, but don't look up at it, look past it, and realise that you are one person on a rock in an entire universe. And the whole point of the Humanity Star and the orbit that I went to and the trajectory and the design of it was that every single person on this planet had the opportunity to see it. It doesn't matter if you're rich or poor, in love or at war, everybody had the opportunity to witness that and experience it. Sputnik was great, but you had to have a handheld radio, which means that you have to have some level of technology within your country. And really, we copped a bit of flack for it, and that's fair enough. But we also, what wasn't so clearly obvious was that just tens of thousands of people that wrote into us and sent us emails that actually took their kids outside and saw it, and really had an overview effect, and realised, you know, the importance of where they are in the universe.
Yeah, and I personally was really surprised at how the astronomical community kind of reacted to it, because you know, during the time period that Humanity Star would be visible, usually that's when your calibration frames are being taken. That's not when you're actually doing your observation.
I mean, it's most visible on dawn and dusk on the horizon.
Yeah, and also things like the International Space Station, Iridium satellites, and satellites in geosynchronous orbit are just as bright as Humanity Star was going to be. So, you know, that was a bit of a surprise with the reaction there.
I think it was good though. I mean, it prompted some really interesting discussion. Like, you know, one of the points was, how can this little company do this? Like, you know, that can potentially affect everybody on the Earth. Like, everybody can see it. So it raised some important questions, and it was really good. And what was really cool is we had a number of people that wrote in and said, you know, because of the Humanity Star, they now want to be astronomers. So I'm like, take that, astronomers, you know.
Nice.
Yeah.
And Humanity Star, is that technically the first New Zealand satellite?
It is, yeah.
Well, there you go.
Yeah.
That's really, really cool that it was able to do that. So there's just some super interesting questions in here. Stormer in our chat room is asking, did anyone in the space industry inspire you?
It's not like one single person that I just said, wow, that person's amazing, and you know, I want to aspire to be that person or anything like that. I guess what my inspiration and what drives me and gets me up in the morning is knowing that this is a really important thing that can have an effect on so many people. And you think about a satellite, it's the only thing that humans have made that have the ability to touch billions of people every day. So if you put up a weather satellite, it provides weather to New Zealand, and then 10 minutes later it's providing weather to Australia, and then 30 minutes it's North America, and then, you know, India, and so on. Like, that one little shoebox piece of electronics has touched literally tens of millions of people's lives. People have decided to get married in that time because of the information of that satellite. People have decided to go to war in that time. Like, that information, like, it touches just so many people, and you can only achieve that from space. So that's what inspires me is the mission. Less people, it's more about the mission.
Is that why, would you say that's sort of an overarching idea as to why, the why of Rocket Lab is to enable that?
100%, yeah. Yeah, when it's all about empowering, you know, humanity's potential. That's what it's about. What can you do in space that moves the needle for the species? That's what it's all about.
Yeah, that's a very good way of going about that. And actually, we've got a question from Ben from our chat room, which is that he heard that there's a really cool story about your wedding ring that you have. So,
well, I mean, I mean, doesn't everybody make their own wedding rings?
No, not all the time. So
yeah. I'm not actually wearing it today because I've got a different one on because I wore it out. So probably not a great story. It's not a great testament to my engineering, is it? I wore out my wedding ring, but the reality is, you know, it's just your standard titanium carbon fiber. Wedding ring.
But you designed it and built it yourself.
Of course.
Yeah, as everyone does.
Yeah, well, my wife spent too much on hers, so that was the only option anyway.
Oh, okay. So did you like make it at home? And
yeah, I mean, I've always had a very large workshop, but no, in seriousness, I mean, I like making stuff. I've always have. So, you know, especially important things. You know, like the Humanity Star. You know, it was important that I made as much of that as I could. I needed my hands to touch it.
How much of it did you actually build yourself?
Well, the one that was on Flight 1, I built the whole thing. The one that was on Flight 2, I ran out of time, so the composites team really built the majority of that one. But you know, it was still really important. You know, things like wedding rings and things like that. They need DNA on them.
And to kind of go back and talk a little bit about that sort of time when you were approaching your first flight of Electron, what were you guys sort of thinking at that time? Like, what's running through not just your head, but everybody at the company when you're coming up on that?
I don't know how you explain that, because you've got a group of guys that have given their life for the last 4 years to get to that point. And you do everything you can. Like, I sat down with our engineering team and said, we're not going to fly unless all of you give me a 92% confidence. So I didn't want any system or any guy coming in there on the first flight unless they had a 92% confidence. And it's a long story about how we get to 92%, but let's just leave it at that.
Sure.
So we arrived on the pad, and it's not fair to say we were confident. I mean, we were confident in engineering, but you don't know what you don't know. We're a very conservative, methodical bunch at Rocket Lab. We don't take risks. Evident right now, if we see something weird, we'll just stop and go and investigate it. And the first flight was incredible. The vehicle performed really, really well. Unfortunately, we had a ground issue with a flight termination system from a third-party contractor. But the vehicle was on trajectory, and everything was nominal. To reach orbit on the first hit.
So it literally wasn't the rocket's fault. It was something on the ground.
100%. No, it was an incorrectly configured flight termination ground software. So I've got that framed, the piece of code. But the reality is, that we are a really, really conservative bunch, and the first flight, it's just one of those things you just can't. I don't know how you can explain it.
Yeah. Did the second flight feel any different than the first flight did? Did you have more confidence?
Yeah, well, we knew we had a very solid vehicle because on the first flight we had 35,000 channels of instrumentation. So there wasn't a thing on that wasn't instrumented. And I was incredible. I was just amazed what the analysis teams could do with that data. Like, we saw an acoustic vibration at 22 hertz, and with the instrumentation on it, they were able to determine that there was a little cavity on the separation lock that caused an acoustic vibration of the air on the way up, and that's where that came from. It's like, wow!
Holy moly!
Yeah, so that's how well instrumented we had the vehicle. So we were conservative. We set our margins where they needed to be, and we could see that we had a very, very solid vehicle, which gave us a lot of confidence to just. At that point, I'm just like, you know what, team, full production. Let's start scaling the factories. Let's just go now. Which we did.
Yeah, and now you guys are coming up on your third flight. With that, and kind of how are things going with that? Because I know you were gonna a couple weeks ago things were set and they were going, and then kind of you guys saw something and
totally
that was again doing the right thing. Better to hold than not have something go wrong.
Here's the reality. In 2 years' time, we can have this interview, and you won't remember the time that we scrubbed twice. But you will remember the time that we blew a rocket up. So for us, we saw some unusual behaviour on a motor controller, and we just like, whoa, we don't like what we're seeing here. So we took our time, went back and investigated. We thought we had it. Clearly we didn't, and we went back out to the pad and we saw a similar thing. And now we really, really understand it, and we've made changes to hardware. We found where the potential issue lay. So this is the thing about it's not just about the rocket. It's about like the investors in the company, and the investors backing the company. And we've got just such tremendous investors. It's not about we're going to run out of money, so let's get this in launch. It's like, no, we do this properly, and we make sure that we're in the best position, and our investors back us to get to that right point. So look, it's not an ideal scenario. We had a much higher flight rate planned for this year, but it's more important to get it right now than go and fly with risk. And it's the way I'm built. I'm quarter Scottish, quarter German, and the rest Kiwi. So I'm tight as anything on money, and then I'm a German engineer, and then a Kiwi innovator. So it's not within our DNA to put something on the pad with high risk and just go. So we just will never do that.
So overall, with Rocket Lab, it is essentially enabling the things that you want to have happen to influence, especially very positively influence humanity.
100%. We go to space to help everybody on Earth. That's the thing, right? I mean, that's what it's all about.
Excellent. All right. Well, Peter, thank you so much for coming on. We're going to ask our standard questions real quick.
Cool.
With it. So these are just 4 questions that we ask everybody. No right or wrong answers or anything.
I'm sure there is a right or wrong answer.
Well, for some of them, I guess, what's your favorite space shuttle? There would be a right or wrong answer with that. Yeah. Well, it depends on who you ask about that too. Yep. But for these, at least, there's no right or wrong answer. So let's just go straight into it. Yep. The first one is, what is your favorite space mission, past, present, or future?
So past would have to be Voyager series. I mean, how cool is that? Sending, humanity's knowledge and wishes and dreams out into the universe. I mean, it doesn't get any cooler than that.
Yeah.
No, I think that would have to be the past. And then future, I'm cooking some stuff up.
Oh, okay.
Yeah.
Well, guess we'll have to have you come back to talk about whatever you're cooking when you're done cooking it. So, so the second one, human or robot exploration of the cosmos?
Robot.
Robot?
Yep.
Why?
Have you seen these bodies? They're hopeless for space exploration. They're so needy. They need food and water and oxygen. No,
So robots, just straight up robots.
Yeah, no. I mean, quantify that. I think there's a deep need for humans as humans to go and explore. That's what we do as humans. But I mean, if you wanted to do some deep exploration and do some deep scientific stuff, go and do that with robots. If we want to go to Mars, then of course, that's a great thing for humans to do. But for right now, I would say that we can learn much more as a species if we just send robots.
Okay, I think you're the first person to actually say just this. I think everybody so far that we've asked this question has been said both, but that's you got a pretty good justification for it. So, third question: where should we go next? What's the next frontier we should go to? So,
well, so I actually think this is once again this is not going to be a popular kind of thing here, but I think we've got stuff to do on this planet. And look, I have a fundamental policy that I'll never fly meat. I'm not interested in human spaceflight. It's obvious from the last answer. I do think it's important, and I think it's aspirational, and we need to do it. Let someone else do it. But I think, as a species, if we just purely think as a species, what can we do? Really, it's let's focus on right here on Earth and building infrastructure in space and doing things in space to understand our planet and improve our planet and improve our lives on planet. So I think where do we go next is let's just hunker here for a while, because this is not a bad place, and then we shouldn't not explore, but I think the focus should be here.
Gotcha. And then the final question, and my personal favorite question: why space?
Oh, gee whiz, that's actually really hard. I mean, I've got my own kind of personal views on what interests in space. I mean, it's just like, how can there be anything else other than space? I mean, it's you think once again, it comes back to a species level thing. You think about human as a species, and we're fragile on this one rock, and everything else is out there. So it's I don't even know how to answer that question. It's just such a crazy question. It blows my mind. Like it's how can it not be space?
Yeah, it's almost like you're in it, so
yeah,
it is.
Yeah,
so,
yeah. You're floating on a rock in the universe of space. So get to know your neighborhood. Yeah,
good way to answer it. Peter, thank you so much for coming on the show today. We really appreciate everything that you answered and your amazing perspective today as well. So thanks so much for coming on the show.
Oh, my absolute pleasure. It's a blast.
Yeah, and we do want to thank our TMRO patrons as well, specifically of the Escape Velocity variety, who helped make this specific segment of this episode occur. These folks give us $10 per episode or more, and if you would like to help out the show, you can head on over to patreon.com/TMRO. Also, don't forget to subscribe on YouTube and hit the bell as well, so that way you get updates, so that you can know when we're going to have awesome people like Peter coming in to talk. And we are going to now go to break, and when we come back, news from the past week. So stay tuned. There's more tomorrow right after this.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. This girl's a fascination, and nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, through the heat keeps on improving. Yeah, she's fire walking to be free.
Welcome back, and as we always like to start the news off with some launches, we've got Mike with a brand new launch minute.
All right, so this week we had a Chinese Long March 3B rocket, which launched on Sunday, July 29th at 0148 Coordinated Universal Time from the Xicheng Space Center in southwest China. The Long March 3B rocket is a 4-stage liquid-fueled rocket with 4 hypergolic liquid-fueled boosters, and the first, second, and fourth stages are also hypergolic. The third stage is actually cryogenic with liquid hydrogen and liquid oxygen. The payload for this mission were 2 Beidou navigation satellites, which are Chinese GPS satellites, specifically the third generation Beidou 3 MEO5 and MEO6, also known as Beidou 33 and 34. Beidou is named for the Chinese word for the Big Dipper constellation, and the development of the Beidou program began in '94 and is expected to have global service in 2020. The first Beidou test satellite launched in 2000, and now 34 Beidou satellites are in orbit. When fully deployed, the Beidou fleet will consist of 35 satellites, including 27 in medium Earth orbit. This was the 21st launch for China this year. However, China had another launch so far this week. They had a Long March 4B rocket, which launched on Tuesday, July 31st at 0300 Coordinated Universal Time from the Taiyuan Spaceport in northeastern China. The Long March 4B is a 3-stage hypergolic liquid-fueled rocket, and the payload for this mission was the Gaofen 11 remote sensing Earth imaging spacecraft. Gaofen means high resolution, and it's a civilian Earth imaging program that provides all-weather global surveillance network and is using a combination of visible light and infrared cameras as well as radar. At least 14 Gaofen satellites are planned for their network. U.S. military tracking data indicated that Gaofen 11 was placed into an elliptical orbit between 245 kilometers at perigee and 691 kilometers at apogee, and was inclined 97.4 degrees to the equator. So it was in a sun-synchronous low Earth orbit. This was the 22nd launch for China so far this year and matches their previous record of 22 launches in 1 year back in 2016. But also we have to root for our favorite underdog, Copenhagen Suborbitals, which had a launch of their Nexo 2 rocket today, Saturday, August 4th, at 7:35 Coordinated Universal Time from the Baltic Sea. It was not a suborbital flight. It only reached an altitude of 6,500 meters, but the Nexo rocket is a technology demonstrator in advance of their much bigger Spica rocket that is going to take their astronaut into space. Nexo is an important part of the Spica technology roadmap, and just as the Nexo 1, the Nexo 2 rocket is powered by their own BPM-5 engine. In fact, it's the same engine that was used on the Nexo 1 flight, and it provides 5,000 newtons of thrust and runs on ethanol and liquid oxygen. Nexo 2 is also guided by their own custom-built guidance and navigation computer, which had some upgrades, and also features a dynamic pressure regulation with a 20-liter helium tank to keep the fuel nice and pressurized for the launch, and the rocket was recovered under parachutes after the flight. Wow. Congratulations, Copenhagen Suborbitals.
You can hear everybody in the studio cheering. Holy crap, like I'm sweating. That was such a good job.
That was amazing.
Oh my goodness.
Thank you. Thank you. Thank you very much.
I'll get back out.
Thank you.
Oh yeah.
Well done. Well done, Mike. Well done. Well done.
Oh.
Super awkward when I do this by myself.
I got you later.
Too late. I was too late.
My goodness. That is amazing.
Okay.
Oh, wow. Definitely congratulations to CopSub, one of our favorite underdogs. Of course, congratulations to Mike. Wow, this is going to be a really interesting way to do launches, but I'm loving it. That's really cool. Really good job. Wow.
Thank
so, Sarah,
Let's
you
move
got
right
some.
along. There's some cool stuff to talk
No,
about.
I know,
Yeah.
right? Wow. Sarah, you have some really big shoes to fill. I'm so sorry.
Yeah, I got big feet, but that's not going to happen.
I love it. So you were talking earlier a little bit about how we're finding things not just based off of luck. What is going on there?
Okay, so back in 2016, a team of astronomers at the Very Large Array, they discovered an object that looked like a brown dwarf.
Sure.
But further study has indicated that it is actually a rogue planet.
Oh, okay.
And what they were looking at the radio emissions. So up until now, our only way of discovering rogue planets was pure luck. We had to have a telescope aimed at a distant star, and then there had to be a rogue planet go in between us and that star, or occult the star. Sounds kind of weird and violent. But it had to pass right in front of that distant star, and then we could use gravitational lensing and just happen to just catch this random action. Now we may have an actual tool for looking at the skies and finding rogue planets. So now we can determine whether or not there are as many out there as we think.
And we're using lasers.
We're using radio,
Oh,
actually.
Just kidding. Okay.
We can use, sure, why not? We're just gonna redshift it down to
Right?
radio.
Exactly. So how does this work?
Okay, so this planet that they found is about 12.7 times the mass of Jupiter.
Okay.
Which puts it just underneath the mass where it would need to be to start burning deuterium. All right. So it's not really producing a whole lot of heat on its own. It's not enough for us to look out and see it as if it's a star.
Right.
So instead, it's got this, just like Jupiter, it has a really massive magnetic field. This one happens to have one that's 200 times the power of
awesome.
Jupiter's magnetic field. Yeah.
So does that make it easier to find then?
Well, there's something that's reacting with that field.
Yeah.
It's got Aurorae, or the equivalent. It's looking like what we see at Jupiter when Io is passing through Jupiter's magnetic field.
Gotcha.
You get these cool Aurorae traveling around the North Pole of Jupiter, and they produce radio emissions very similar to what we saw on this
That's awesome.
rogue planet.
Right.
All right, and
that's
so
why I'm looking at it.
Yeah.
yeah,
Okay,
so we think
cool.
it's got a little binary or a moon or something that is creating this interference in its really powerful magnetic field, and that's producing radio emissions that we can detect. So
Nice.
not only are we learning more about really strong magnetic fields, so we're learning more about extrasolar planets, and we can maybe find those rogue planets that we've been looking for.
That's awesome. So why, I don't want this to sound bad, but why do we care?
Why do we care? Well, because awesome.
I mean, yes, awesome.
No, so I
love it.
With the occultation process and the micro lensing, it looked like there were fewer rogue planets than we thought, and the way we have figured that stellar systems form, planetary systems, predicts that there will be a lot of planets just
And we just weren't
ejected.
finding them?
We weren't finding them. We were
Got
finding
it.
like 1/5 of what we expected, or some crazy small number.
Right.
And with this, we might be able to find more and really solidify our yes. We know how planetary systems formed. We're not just
love
making
it.
this stuff up.
Nice. So we're either gonna totally prove ourselves right,
Yes.
or really disprove ourselves
Or
and go,
really,
oh
yeah.
man, we don't know nothing.
But if we found this accidentally using a different process for something else, odds are pretty good that there are more that we'll be able to find.
Yeah,
So we're probably going to prove ourselves right.
that's awesome.
She said very hopefully.
Right, exactly. Mark these
Makes me
words.
wonder-
That's very, very
It makes
cool.
me wonder though whether or not they would this be only strong enough? Would these type of instruments only be strong enough to detect really strong magnetic fields, or would we be
Yes.
able to find even other smaller objects that are weaker?
Well, since this one was found by accident and it took several years to realize, oh wait, this is, initially it was thought to be a brown dwarf that was really old and cool. Now it turns out to be a really young, really powerful magnetic field around at a young rogue planet. So as we fine tune what we're looking for, we should be able to find smaller and smaller. Just
Nice.
like with transits. We've been
Gotcha.
able to get smaller and smaller detections.
Nice.
Yeah.
To the point where we could start seeing other, how do you say it, Oumuamuas, the interstellar comet?
I don't know that Oumuamua has quite the magnetic field that we
Or
would
any
need
of
to
the
produce
others.
that. But if we look at these things, we find that there is the disturbance in the magnetic field, and that means there is a partner with it. So it's not just a rogue planet; it's a rogue planetary system. It's a planet with moons. So
Oh, sure.
we could be finding captured asteroids as well. So we'll eventually get there,
That's awesome.
maybe.
That is awesome. All right, see, now I care too. Beautiful. So, Mr. Mike, we were talking a little bit earlier about, human spaceflight is one of the things we love to discuss around here. So, there's some interesting things going on in commercial crews. Why don't you go ahead and fill us all in?
So yesterday, on Friday, August 3rd, NASA officially announced who the astronauts are going to be on the first commercial crew missions. And, oh man, the commercial crew missions heading up to the International Space Station. So this is a big deal. I'm really excited for this. The agency has assigned 9 astronauts to be part of both the demonstration flights and the actual missions of both Boeing's CST-100 Starliner and SpaceX's Crew Dragon. NASA has worked really closely with both the companies throughout the design, development, and testing to make sure that the systems meet NASA's safety and performance requirements. So let's just go ahead and jump right into who the astronauts for these flights are going to be. For Starliner, the first pilot is going to be Eric Boe, who was a colonel in the Air Force as a fighter pilot and test pilot, and he was selected as an astronaut in 2000 and piloted the Space Shuttle Endeavour for STS-126 mission and Discovery on its final flight for STS-133. But then we also have Chris Ferguson, who is a retired Navy captain who piloted Space Shuttle Atlantis for STS-115 and commanded Space Shuttle Endeavour on STS-126 and Atlantis for the final flight of the Space Shuttle program, STS-135. He retired from NASA in 2011 and has been an integral part of Boeing's CST-100 Starliner program, and happy to see that he's part of that. Next, we also have Nicole Mann, who is a lieutenant colonel in the Marine Corps and a test pilot. Mann was selected as an astronaut in 2013, and this will be her first trip into space. Oh, man. But as for the Starliner's first operational mission, those 3 crew members will just be for the crewed demo flight. For the first operational mission, we also have, Bob Benkin, who has a doctorate in engineering and is a flight test engineer and colonel in the Air Force. He joined the astronaut corps in 2000 and flew aboard Space Shuttle Endeavour twice for the STS-123 and STS-130 missions. And then we also have Doug Hurley. He was a test pilot and colonel in the Marine Corps before coming to NASA in 2000. He piloted the Space Shuttle Endeavour for STS-127 and Atlantis for its final flight in 135 for the final Space Shuttle mission. And excuse me, those 2 gentlemen are actually going to be for the first Crew Dragon test flight. For the first operational flight of the Boeing CST-100, it's going to be John Casada, who is a Navy commander and test pilot. He was also selected back in 2013, and this will also be his first space flight. And he's going to be joined by one of our favorites, Suni Williams, who is a retired Navy captain and test pilot, was selected for an astronaut back in 1998, and she spent more than 322 days aboard the International Space Station for Expeditions 14-15 via Space Shuttle and for Expeditions 32/33 via a Soyuz. And she was also the commander of the space station for Expedition 33. And she also performed 7 spacewalks. So, gotta love Suni. She's one of the best. I really love her. But for the first Crew Dragon operational mission, we have Victor Glover, who was also selected in 2013 as an astronaut. He is a naval aviator, commander, and test pilot, and this will be his first space flight as well. And then joining him will be Michael Hopkins, who is a colonel in the Air Force, where he was a flight test engineer before being selected as a NASA astronaut in 2009. And he has spent 166 days on the International Space Station for Expeditions 37/38 via a Soyuz and conducted 2 spacewalks. And probably the thing that is most exciting to me about this is there's going to be additional crew members that are going to be assigned to at least the operational missions of these commercial crew vehicles. And those people are going to be assigned by the international partners of the International Space Station at a later time. So we might see some JAXA astronauts on there, we might see some ESA astronauts on there, and maybe even some Russian cosmonauts as well. But meanwhile, NASA has announced delays in when the first flights may occur. Boeing will have their first uncrewed test flight late this year or early next year, followed by a crewed flight test in mid-2019. And then the updated schedule for SpaceX has an uncrewed test flight this November and the first crewed flight test in April of 2019. Whew. So the reason we care about this so much is because commercial spaceflight, of course, is getting closer to becoming a reality and being available to the rest of us. Something I'm really excited about is that Boeing is already marketing the CST-100 spacecraft through Space Adventures, which offers tourist flights to the International Space Station. They've also partnered with Bigelow Aerospace once they have their own free-flying commercial space stations to transport people. SpaceX also has a deal with Bigelow as well to do that. So I'm just really excited because even though at first it's going to be, the very wealthy or, experiments that are extremely important to mankind, more and more people are going to start going into space because of these vehicles, and I'm so excited for it.
That is really, really cool. Very, very fun. Yeah, gosh, I have so many things that I want to say. I want to go, but I only want to go with Ike. Victor also goes by Ike because they like the Mike and Ike combination there. So one day, if you ever see me wearing a Mike and Ike shirt, that's definitely for them. Very, very cool, Mike. Thank you. I appreciate you sharing. Yeah, exactly, right? So, Ms. Sarah.
Okay.
While we were talking about other luck
Yes.
and things. You told a really interesting story earlier. Jared came in and said, so why did you pick the stories that you did? Or like,
Yeah.
what are you talking about?
Yeah.
And so we already talked about the one.
Yep.
But then the next story that you told him, if you wouldn't
Yes.
mind actually repeating, because I think you said it so perfectly and summed everything up, and I was like, I want to hear more about that.
No pressure, right?
I know, right?
So say it exactly the way you did before when you were just talking with somebody.
Right.
All right.
Yeah, precisely.
Okay, so there was this group of people, they were studying asteroid impact ejecta rays. You know, so we've all seen the images of, we've all looked up at the moon and seen the Tycho crater, and it's got these rays coming out of it. And
Because they don't look like rings, like you would think
Yeah.
that you throw like a rock into water and you
and
get
it's
the
a
rings.
smooth ring, right? We see fingers of debris sticking
Yeah.
out, and well, there was a team studying it, and they were in a lab, and they were trying to replicate those rays, and they were not having any luck. So they went to YouTube, and they were looking at other people's work, seeing if anyone else was having better luck than they were at replicating these rays.
That's so smart.
Right?
I'm not gonna lie. That's
YouTube.
amazing. Right? Exactly. What a great
Go to
use
the
of
YouTube.
YouTube. Learn science. Yes, go on.
And they found some high school students. They were throwing rocks at a sand pit, and they were replicating the rays.
Shush.
And I know. So what they went back to their lab and they started messing with the size of the grains and changing the radius of the object that they were dropping into it. And they couldn't get it until one day, one of the undergrad or postdoc, whichever it was, he was so tired he didn't bother resurfacing their precisely calibrated sand pit, and he had the ripply leftovers from the last impact. Dropped the like dropped their little 1.2
Sure.
gram thing, and got the raise.
And got the right results.
Yeah.
That's so amazing. Think about that. Okay, so what does this mean now?
So this means, well, we can look at craters on other planetary bodies, the moon, Mars, Mercury, and we can figure out from the rays what the surface looked like before the impact and how big the impactor was. By
Nice.
knowing how many rays you see.
That's so awesome.
I know. Okay, I mean, it'll take, of course, more refining.
Yeah, sure, but
again, luck.
Totally.
Is just, I can't even express how awesome this is.
That's
It's
what I'm
just
saying. See,
the
I'm like, now
world-
I want to know more about that. That's so cool.
Yeah, we're getting, internet is making world science.
That's awesome. Like how. Oh my goodness. And I know I talked all over your story. Is there anything else that you
No.
wanted to add to that in case there was, I want to make sure that you got all of your information in, but that's so cool. That's so cool.
Yeah.
So the best part is it's essentially you could recreate this at home if you really wanted to.
Yeah. Yeah, you can just plunk a stone
Hey
into
Lisa,
a
you're paying
ripply
attention,
sandpit.
right? So we can do this on a science episode later? Good.
Okay.
I'm just making more work for Lisa as we do. All right, that's awesome. All right, so what we're going to do now is we're going to give the thank you that is so deserved to our Escape Velocity citizens. These are the people who've given us $10 or more per episode, and they've made this segment happen. And also our Orbital citizens. These people have given us $5 per episode, and they help make the show happen week after week, as you can as well. You can always hit up patreon.com/TMRO, and also really, if you don't have the time, just go ahead on over to youtube.com and /TMRO, and then hit the subscribe button and hit the bell so you can get ideas of when we are going to be on next, because every little bit helps, whether it's time or money, and we appreciate all of it. And next, what we're going to do now is we're going to go into another little bit of a break, and then we're going to come back with comments and questions about last week's show. Stay with us.
Science. It both draws us together and tears us apart, brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Welcome back. So this is where we go over your questions, comments, concerns, complaints about last week's show. Last week, we happened to have Bruce Bannert, which is, he was the principal investigator of the Insight mission from JPL. Principal investigator of Insight mission. I just want to make sure I actually said that correctly. And it is Bruce Bannert, not Bruce Banner. There was some little bit confusion over that as well. Not the Avenger. I apologize for that. In any case, all of these comments, I believe, came off of YouTube directly. But you can always also put in comments on our community.tmro.tv as well. It's a lot of great conversation going on over there. Anyway, first comment is from Jack Speed 439. Says, on the risk front, shuttle was dangerous. We're now on the Soyuz. How safe is that? So we shouldn't go backwards, so that puts us at requiring safety at least as safe as Soyuz. As we stuff around demanding safer systems from Boeing and SpaceX, we are using a less safe Soyuz system. Therefore, demanding/requiring unbelievable high safety standards is actually lowering safety standards. There was an interesting debate about this on YouTube, ironically, a little bit between Dutta and Ben Credible, as a matter of fact. I'm sure they're both steaming about it, but we haven't heard from anyone else here, so I'm sure, Jared, did you want to go first on that one?
Yeah, I mean, Soyuz, the Soyuz and shuttle are about the same in terms of
safety?
Total safety when you look at all of Soyuz. But if you look at just Soyuz that has flown crew, Soyuz is actually significantly safer than Space Shuttle is.
Interesting. So, yeah. All right, Mike, it sounds like you had some 2 cents to add there.
Yeah, no, I completely agree. The Soyuz vehicle for humans is very safe. And I mean, there's a reason why they've been flying it for so long and all the incremental improvements that they've made. But I kind of agree with Jack Speed here that, demanding these higher safety standards than even what the Space Shuttle was held up to is a bit realistic. We've talked about that before. So yeah, I don't know about if it's lowering the safety standards of, I'm assuming he means Soyuz, but there's different systems for everything, and compromises are being made so that we can actually begin flying safely. But there's going to be an amount of risk no matter what we do. We're flying on rockets for crying out loud.
For sure. As Pete said earlier, I'm not about to fly meat. So I think that is an important thing to note, that there's some inherent risk anyway. Sarah, did you have anything else you wanted to add?
Oh, no, I think it was all said.
Yeah. Perfect. All right.
Soyuz is one of my favorite crewed spacecraft. Just throwing that out there because it's literally like, why reinvent the wheel kind of with it,
Right. Crewed isn't human rated, by the way, not CRUDE. Just want to be very clear about that.
Just following the official guidelines as to how,
Absolutely.
the official NASA guidelines as to how you refer to spacecraft.
Yep. Totally agree. All right, so next comment comes also off of YouTube from one little cripple. Says, I'd love to see that people who don't want to colonize space would say, if we found an asteroid coming for Earth, they'd be on the first rocket out of here. I mean, I guess, yes and no, right? Who wants to go first on this one?
Oh, my.
That means Sarah. Yes, ma'am.
Apparently. Well, wouldn't we all be on the first rocket? I think the choice is, do we colonize for the hell of it, or do we get off of a sinking ship? It becomes a completely different argument at that point.
Right.
So I can't really fault them for saying, let's stay here on Earth, and then when Earth is doomed, let's go somewhere else. Okay, but on the bright side, if we had the time to evacuate from Mars, we would have seen that big impactor coming, and we would have options to redirect it. So probably colonizing at that point would be the best choice.
So it's either do it now and or later. Yeah, you're still doing it, is what I'm hearing.
Yes.
Right?
Yeah, it's going to happen. You don't have to go if you don't want to. It's going to happen.
Right. Yeah. All right. Awesome. Yeah? I know. This is what happens when we all agree on things. So I apologize.
I personally want there to be as much survivability as possible. So, if this were to happen today, how many people would survive?
Right.
12? You actually get off planet was their survival? 12 people, maybe?
Right.
But if we do this later, when we've already colonized Mars and everything, that way we can ensure at least several hundred thousands, millions of people can survive.
Right.
Not to save
If we're doing
everyone,
it anyway, the sooner we do it, the
as
safer
many
it's going to
as
be.
possible.
Yeah.
Yeah, and survivability with this even, depends on how much of an advance warning you have of the object inbound as well. If you have enough time, which by the way is not, what was it in Armageddon, 14 days? Or
Yeah,
what was it?
yeah.
Not enough time.
21 days or something?
Yeah.
I don't care what anybody says. Armageddon's one of my favorite space movies because
Love
it's
it.
practically an art film, okay?
amazing.
It just doesn't try to BS you or anything. It's just like, this is what's happening, and we're going full throttle with it. So I don't care what anybody says. It's one of my favorite space movies.
Dude, I need to high five you later.
But we need like 15 to 20 years advance warning for something like that. So yeah.
Well, it's movie time, though. Just shrunken down into days. It's fine.
Yeah.
Each day is like a year.
Each day's a year. There
I
you
mean,
go.
Billy Bob Thornton would make a good NASA administrator. I
I'm
feel.
on board with everything he
I'm
says.
throwing that out there. So,
And any asteroid should run scares if we throw Bruce Willis at it.
that's right.
Oh, that's funny. All right, so the next comment, I actually have two comments that are back to back. One actually speaks to the other one, just so Donna is aware of that. The first comment comes from YouTube. It says, from Unpainted Lead Syndrome, says, "Oh, Bannert. I kept hearing Banner. Bummer. I wanted to hear more about his radiation research. Turns out it's just rocks on Mars." To which Zapfan also on YouTube replied with, "There really should be a gamma instrument on
Oh my
InSight."
gosh.
And that's what made me laugh.
Y'all are a bunch of dorks. But that was good.
What? I
That's
love
pretty
it.
good.
I think that's amazing. I
I
was
gotta
sad
say.
I didn't have an Incredible Hulk t-shirt to wear that day. I thought that was
man.
right. Exactly.
I do have one hanging in my closet though,
no.
and I apologize.
Oh, that's all right. This
For my
is
nerd
still
fail.
a good
No,
one.
that's okay, because then we would have had to apologize after the fact to the guest for
Right?
yeah. So
Yeah,
no,
no,
it's
it
okay.
was gonna
Things
get really
happened
messy.
the way they were supposed to.
Very quickly. All right, and then our last
No Hulk
comment for this
smash.
episode from also from YouTube from one Ronald Shiflett, I believe, says the names of the drone ships are not just quote unquote quirky; they're literary references to important sci-fi. This created quite a debate on YouTube, and if you're interested in all of it, please feel free to go over and hit up our YouTube channel. I just wanted to use this really quickly to say, they're still quirky. I mean, they just are.
Yes, they are.
Yes, they are literary references to sci-fi. I think everyone has their own identity of what important sci-fi is. You said Armageddon's your favorite space movie. Mine's The Core.
It's not my
So, I mean,
favorite space
wow.
movie. It's
Then-
just one of my favorite space
Oh,
movies.
I apologize. I apologize.
Oh my gosh.
Okay, my favorite space movie is The Core. So I will just
amazing.
put
I
that
worked
out
at
there.
I have worn that suit.
That's amazing. We have so much to talk about in After Dark now. But that is to say, like, we all different backgrounds, we all have different focuses, et cetera, and as do you, and that's what makes this entire community that much better.
Yeah, and
we're doing it together.
Not everybody's going to understand every reference that gets thrown out there, and that's
sure.
perfectly fine because that opens up an avenue for someone to then go out and actually look at that reference, understand it, see where it's come from, and then decide whether they want to pursue it or not.
Yeah. Precisely.
And that's like a really great. That's a really great thing to do because it doesn't gatekeep. It doesn't keep this to a certain degree of people. You have to have this kind of an IQ in order to understand.
Right.
Shut up with that noise.
I think right.
It just allows it to open it up, and that's what makes it so great when people do things quirky and out of nowhere and just out of left field like that.
I think it's one of those things where it feels to me of it's the old adage of if you love something, let it go. In terms of like, look, Elon named these ships. That was his reference that he really liked, and he wanted to share it with people, whether or not they got it. And then that gives an opportunity for somebody to look into it more. And you're right, and maybe find something new that they absolutely love, or they kind of go, no, that was total crap, but Tolkien's the man. Like whatever you like, man. Like it's totally cool, and we like all of it. So
Of course we still love you.
of course we still love you.
Yes.
See what you did
Don't
there.
forget to read the instructions.
So good. So good. All right. So I want to make sure I give a thank you, a very well-deserved thank you to all of our citizens that have helped make this amazing episode happen. Our escape velocity citizens at $10 an episode, our orbital citizens at $5 an episode, our suborbital citizens at $2.50 an episode, and our ground support citizens. Absolutely everybody here matters. Help continue to make the shows happen week after week. These are obviously community driven. You can head on over to patreon.com/TMRO, and don't forget to subscribe on YouTube and hit the bell so you're notified about all of these awesome episodes.
Yeah.
Yep. Wherever
I don't
the
know
bells
where it
are,
is. Is
they're
it down
here
here?
somewhere.
Is it here?
Yes. Next week we have actually Mr. Chuck Ryan, who the shuttle trainer, Resolution, and NASA. So we're going to be talking about a lot of interesting things. That is a really cool picture. I really like that.
How do I get one of those?
like an
Maybe you
airplane
can ask him
sample
next
of
week.
How many dollars? I need?
That's all we've got for this week. Thank you so much for joining us and in our discussion. It was such a pleasure. We'll see you guys next time.